So here we're going to find the Taylor series, radius convergence, interval of convergence. Now this one, what we're going to do is we're going to use any tricks that are necessary, and I'm going to use existing series. This should say just find the power series. Okay, so cosine of x is you want to memorize the formulas for basic ones. Cosine's even, so it's going to go -1 to the 2n over 2n factorial x to the 2n. So when I do cosine of x squared, I just have to use this same series, but I just replace x with x squared. Oops. -1 to the 2 to the n, 2n factorial, x squared to the 2n. That ends up being x to the 4n. Okay. Now to find the radius and interval of convergence, I actually look at the original one. So what was the radius of convergence for these? These, I think these always converged. But if you don't remember, you can always just do limit comparison, right? Just do our rules. But if you can remember the regions of convergence for each of these, I thought it was infinite, like the ratio is infinity. And usually when you have a factorial, that is the case. So it's going to be x to the 4n plus 4, because I'm doing n plus 1 here, over 2n plus 2 factorial. I'm doing the ratio test. It's going to be 2n factorial over x to the 4n. That's going to be x to the 4th. And that's going to be this is going to be x to the 4th limit n goes to infinity 1 over 2n plus 2, 2n plus 1. And that's equal to 0. So always converges. Radiance is infinity, and then negative infinity less than x less than infinity. Those are the radius of convergence and the interval of convergence. Okay. So yeah, so cosine x always has the converges for all values of x. So if I just square it, it's still all values, right? E to the negative x squared. Well, e to the x is given by this series. N equals 0 to infinity, x to the n over n factorial. So I just replace x with negative x squared. So it becomes n equals 0 to infinity, negative x squared to the n over n factorial. And that's sum from n equals 0 to infinity. This is going to be -1 to the n, and then x to the 2n over n factorial. And again, the radius of this convergence is infinite because this original one has a radius of convergence infinity. Okay. Let's look at number 5. Sine of 2x plus 3. Well, sine x has this function, n equals 0 to infinity. It's -1. It's odd because sine is an odd function. That's how I remember it. So I do the 2n plus 1. But this time I'm going to replace x with 2x plus 3. Like that. And because sine has infinite radius of convergence, so does this one. We'll see ones, I think there should be problems where the radius of convergence isn't infinite, so we'll see how to convert the radius. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.